Welcome to the course on Oracle Database 12c Multitenant. In this course, we'll be covering the multitenant feature of Oracle Database 12c in depth. Multitenant is a new architecture for consolidating databases and simplifying operations on the cloud. Course agenda. In this course, I plan briefly to review the computing landscape in order to explain why Oracle needed to rethink their architecture for the cloud. I'll discuss the new multitenant architecture along with the capabilities or features that it enables. We'll talk about management of shared resources and how to upgrade to multi-tenant. Finally, we'll discuss some of the principal situations in which we expect customers to benefit from this new architecture and look at some customer feedback. Redesigning for the database cloud. Considerations made while designing Oracle Database 12c. Industry trends. We always start by talking to our customers about the pressures and challenges they are facing and what trends they are seeing in the industry. Some things don't change. They face the same pressures and the same requirements as ever. Pressure to do more with less. Agility. Be faster, leaner, cheaper, and deliver services 24/7. Big companies have achieved scale of operations and now they want to realize economies of scale. As always, DBAs are faced with the challenges of patching and upgrading large number of databases and provisioning new ones. The requirements are also familiar and more or less unchanged. Performance, scalability, reliability, and high availability are non-negotiable. Security is threatening and tenant isolation is critical. No time to stop and retool with new applications. What are the solutions? The trends are what is new. These are the techniques to use to respond to these pressures within the constraints of the requirements. With the advent of cloud computing and availability of massively powerful servers such as Exadata, customers want to consolidate many applications into fewer, larger servers. This results in virtualization of shared resources such as servers, applications, and databases. There is a move to standardized services, even self-service. In earlier days, DBAs used to be heavily loaded with work. To respond to business needs or application changes that were originated by the business, DBAs sometimes had to used to estimate weeks or months to carry out database activities required by the applications. These used to be the main bottleneck in implementing changes that were critical to business. Due to these delays or increase in time to market, it would sometimes defeat the purpose of implementation of new changes to applications. So customers had to shelve their upcoming projects for lack of adequate manpower to service their requests. Oracle Database 12c has been designed to solve these recurring DBA problems or overheads with the objective of expediting implementation of new applications or changes to existing applications. Private database cloud architectures. Companies have tried various approaches to consolidation in order to realize the benefits of managing many as one. In previous database versions such as 11g, the data-centric approaches that were taken are akin to the current private database cloud architectures. When we say private cloud, it is identical to the previously called data-centric approach, where servers, applications, and databases were consolidated in the data center that was owned by the customer's IT department, and all businesses were serviced through this data center. It is possible that the customer, businesses, or business users would span several geographies, and the data center would also be split into multiple units of what is technically known as clusters that would also span multiple geographies. In the new world, this is the same architecture as what is known as private cloud. The question arises as to why there is a change in terminology. The change has come because a lot of customers have decided to outsource their IT functions to service providers or DBAS or SaaS, database as a service, system as a service vendors who are servicing multiple customers, and these vendors are using cloud technology, both private and public clouds, to simplify their operations. Oracle Database 12c and Multitenant are designed to help such customers and vendors to consolidate and manage these operations. There are several approaches that are possible in 11g or earlier versions of the database. One approach is to partition a powerful server between several virtual machines, one per application. A downside of this is that you have the resource and management overhead of operating systems and RDBMS per VM or virtual machine, that is per application. Another downside is that you have replaced physical mesh with virtual mesh, and virtual mesh is still expensive to manage. In the dedicated database model, we have a single physical server supporting multiple databases, one per application. The downside is the RDBMS process and memory overhead are replicated per application. In 11g and earlier versions, the highest degree of consolidation could be achieved by what is called schema consolidation. In this model, we have one big server with one big database Individual applications are installed in separate schemas or table owners. Database overheads are shared between all applications, which affords maximum consolidation. Shortcomings are that application changes are often required. There is no tenant isolation. Data confidentiality and security is implemented at application level, and there are several drawbacks. Like same schema name and username cannot be duplicated between different applications. If schema name is duplicated, consolidation will fail. So it will involve massive changes in second application to change schema name across the board. If username is duplicated, it will be allowed but treated like the same user. So in case users with the same name are different, like for example, Rajesh in ERP application may be different from Rajesh in CRM application, the consolidation process will not distinguish and rights will be assigned to one user only. So it's a potential security risk. Also, public or private access to Oracle tables is common for the whole Oracle instance and hence cannot be set differently for each application. There could be conflicts in the DBA functions between different applications. One bad apple can spoil the whole batch. Multitenant is intended to solve these potential problems in schema consolidation. In Oracle Database 12c, we introduced Multitenant, Oracle's new architecture for consolidating databases in the cloud. This delivers all the resource utilization advantages of schema consolidation with none of the downsides. Oracle Database Architecture. Let's think about our traditional Oracle Database Architecture. Every time we create a database, be it a production database, a development or a test database, what do we exactly do? We create a set of files, we allocate a bunch of memory for managing the data, and we kick off a series of background processes. And this is replicated for every one of the databases that we create. As more and more databases are fired up, these replicated overheads quickly consume the available server resources, and this limits the number of applications we can run on any given server. You can see how quickly the little resource meter on the right enters the red zone by this approach. That automatically puts a ceiling on the number of applications or databases that can be consolidated on a single server. New multi-tenant architecture. With Oracle Database 12c, we have a new multi-tenant architecture featuring pluggable databases. We can now create a single multi-tenant container database. In this, we can plug multiple pluggable databases. Pluggable databases loaded into a single container database, which from a system resources point of view functions as a single database. We can see that with this approach, the drain on system resources is drastically reduced, as indicated by the small meter above. Now the beauty of this new architecture is we don't need to make changes to our existing applications. More importantly, we now only allocate one chunk of memory and one set of background processes for the container database. There is a single SGA and single set of background processes. So that's going to give us much greater utilization of our existing IT resources. We'll be able to host many more applications per database server. You can see in the above example, system utilization is drastically reduced. So it's going to give us much greater scalability as we consolidate multiple pluggable databases into one new multi-tenant container database.